This lesson is on direct and inverse variation. We're going to start out with direct variation. And direct variation equations look like the form y equals k times x. It looks very similar to a linear equation because it is a linear equation. But you'll notice there is no plus b at the end of it because the y-intercept has to be 0 for direct variation. We also use k instead of slope, instead of m, because k stands for a constant. Y varies directly with x by a certain constant. For example, if you look at the circumference formula, you'll see that the circumference varies directly with the diameter by a constant of pi. Pi is 3.14. And that gives you this equation that you see to the right. It is c equals 3.14d, or y equals 3.14x. That's going to be direct variation. Another direct variation example here is if the price of a Coke is $1.50, then the price you pay varies directly with the number of Cokes that you buy. You can see here that a Coke would be $1.50, so P equals 1.5C. Again, it goes through the origin. So if you're looking at a graph and trying to determine if it's a direct variation, you're looking for two things. Is it a straight line, and does it pass through the origin? If it does those two things, then you're looking at a graph of direct variation. If you're trying to determine if information in a table is direct variation, you're going to be trying something different. We know that we still have the formula y equals kx. So that means y is equal to the constant times x. Well, if we try to solve for k, we would divide both sides by x. So k would need to equal y divided by x, and k is constant. So you're looking to see in the table if y divided by x is always the same. 12 divided by 3 is 4. 16 divided by 4 is 4. 20 divided by 5 is 4, and 24 divided by 6 is 4. Since this is constant, this is an example of direct variation. With inverse variation, y varies inversely with x, and you get an equation that looks like y equals k divided by x. If you're talking about the rate you drive, if you're going to drive 60 miles, the speed that you need to drive is going to vary inversely with the time that it takes you. And when you graph this, you're going to get a graph that looks like this. There are two curves, and you'll notice neither one of them ever crosses either axis. That's what an inverse variation graph looks like. And for now, just being familiar with what the graph looks like and what the equation looks like is plenty. We'll get into later more in-depth reasoning behind all of this. If you're looking at a table and trying to determine if a table is inverse variation, again we're going to look at the equation and solve for k. So y equals k over x. To solve for k, we'd multiply by x on both sides. So x times y would need to equal k. So you're looking for the product of x and y to be constant. 20 times 1 is 20, 2 times 10 is 20, 4 times 5 is 20, and 5 times 4 is 20. Since x times y is always the same constant, that means this is an example of inverse variation.